Circles are mysterious things, but the only thing that we need to concern ourselves with in this unit are the circumference and the area. The circumference is the distance from start around the outside all the way around to the starting point again. So if you were to cut this and make it into a straight line, that total length is the circumference. And that is the same as taking this diameter and multiplying it by pi. So the circumference could be written as pi d, which is this equation here, or we could refer to it as 2 times the radius, which is the diameter, and then multiplying that by pi, and that's why you get this other equation, 2 pi r. The area of the circle is found using this formula instead, so it's pi r squared, but if you wanted to use the diameter you would use d squared over 4, but to be honest you never really need this. Whenever you're given a circle with a diameter, just halve it to find the radius and use this simpler formula. In this first worked example, it's simply asking for us to find the circumference and the area of this circle. If we were to use the radius for this, then we would use the first formula for both. So the circumference would be 2 pi r, which could be written as 8 pi. You could write this to one decimal place, which would be 25.1. But in either case you would need to write the units, which would be centimeters. To find the area is pi r squared. And when r is 4, this becomes 16 pi. And if you were to type that into a calculator, you'd find it's 50.3 to one decimal place. But the units here are centimeters squared because it's an area. I should write in brackets after this 1 dp to show that it's one decimal place. In the next example, it's asking us to find the radius of the circle if its circumference is 32. So the distance around the outside of this circle, the circumference is 32, but the formula for circumference using radius is 2 pi r, which is 32. When we're trying to find r, we divide both sides by 2 pi, so 32 divided by 2 pi, and then that would give us 16 over pi, or you could write that to 5.10. That would be 2 decimal places. Because the radius is a length, the unit here would be centimeters. If its area is 14.3, then we just use the formula for the area instead of a. So it would be pi r squared equals 14.3. And then dividing both sides by pi first and then square rooting. So r squared would equal 14.3 over pi. And then the radius would be the square root of that. Remember, when you square root, you could get a plus or a minus. If you had a negative radius, then that would be the same as a positive radius, but going in the opposite direction, which would yield the same circle. But we would normally just write the positive square root here. And in the calculator, let's do that. 14.3 divided by pi, and then square root that answer. It's 2.1335, which I'm going to say is 2.13 to 2 decimal places. And the unit here, because I'm finding the radius, would still be centimeters. Okay, in this last worked example, to find the area of this door, it contains a semicircle, semi meaning half, and a rectangle. So we would, to find the total area, we would do area of total would equal the area of the semicircle plus the area of the rectangle. So the semicircle will be a half of pi r squared, and the radius is 40. And the area of the rectangle is simply 80 times 160. Now, I wouldn't put this into a calculator yet. I would put the whole thing into the calculator at the end. That's just common practice to avoid any premature rounding errors. So I could in fact put all of this into the calculator now, rather than writing what each individual part would be. So pi times 40 squared divided by 2. I press equals. This will give me 800 pi. And the 80 times 160 I could leave my answer like this, but it's likely to be asking, likely to be given in as 3 significant figures. So then I would add 800 pi to that to find that the total area is 15,313.27 blah blah blah, which I will write as 15,300, and the units here would be centimeters squared. Right, have a go at the exercises.